I'm Saihaj. I'm a software engineer at the Guild. I work on Web3 initiatives at the Guild. I'm one of the maintainers for GraphQL JS, GraphQL CodeGen, and many other tools in the GraphQL JavaScript ecosystem. Today, we're going to talk about blockchains and GraphQL. I promise I'm not here to sell you any NFTs or meme coins. I'm just here focusing on the tech stack and how it is being used in the industry. I hope after this talk, you know basics of blockchain, learn about what indexing is, and how GraphQL is being used in this industry. So to start with, what is a blockchain? It's a type of a data storage solution where the data is organized into blocks, and each block is linked to a previous one. So it's forming up a chain. Data is chronologically consistent, making it difficult to alter any previous state of the data. Because if you change the previous block, you have to amend everything. So there's some security factors that it just essentially enhances the security of the data. And why we need cryptography in blockchains? Because the bigger piece for blockchains is having cryptography. I'll cover some terms, then we'll get into the cryptography piece. So you may have heard blockchain nodes. So what a blockchain node, it is essentially a machine that is running the software for your blockchain. It is the actual VM machine or container, you could say, that is storing the data for the blocks, different blocks. When you run multiple nodes and put them on a network, it becomes a blockchain network. So now we have a thing that is called a network. We will write to a blockchain network depending on the consensus methods. So this is where the cryptography piece comes in. How you want to store the data, how it's written. There's a consensus mechanism that is being done to validate the data and store the state. So in a network, all the nodes are replicating each other, essentially creating a resilient network. So if one node dies, the other node could serve the data. The decentralization aspect in blockchains comes from the fact that there's no single entity running the node. I could be running one node, you could be running one node, all of us could be running a node. And the cryptography piece makes sure we're always storing the consistent data around the network. And yeah, securing the data, cryptography plays a big role in it. You may have heard these names around, Bitcoin and Ethereum. They're very popular blockchain networks. They both have a different type of consensus mechanism to decide how they want to store the data and how the network operates. So now we know about like blockchain, how the network is formed, what nodes do. Let's go into what is meant by indexing. Why do we need indexing? Why do we need to structure this data? So going back to my previous graph, we talked about the data is in a chronological order. If you look closely, this is nothing but a doubly linked list. Head of this list is on block 3. So if you want to read state of block 1, you need to iterate to block 2 and then go to block 1. A very simple example. Now imagine you have a very large blockchain, thousands of blocks. So if you're at block 1000, you want to read the state at block 1, you have to iterate through the whole linked list, get to the block 1. So as we add more data, it becomes computationally expensive to read the data on the blockchain. That is the biggest problem in blockchain, how to read data effectively. Enters the graph. It's a decentralized indexing protocol that facilitates efficient data query from blockchain networks. My next 2 slides should hopefully summarize what the graph does. So I have a GIF here. This is how blockchain data, you can use this analogy. And when we try to index the blockchain data, you can imagine we're putting everything in a colored order. So before the graph, to fully appreciate the advantages of the graph, it is important to consider how things worked before introducing any indexing. So prior to graph, applications would directly connect to a blockchain node. So in my previous slide, you saw that it's a linked list. So all the transactions, all the data coming into a blockchain is in a linear sequence. This means if you want to read something on a particular block, you have to iterate through the whole linked list. And traversing down a linked list is computationally expensive as you add more data. So the linear nature makes it very inefficient to access this data. So now imagine you're building a front-end app, your user comes in, you don't want to take more than 2 seconds to load the page, otherwise everyone will bounce off the site and no one's going to use it. Enters the graph, which transforms the data retrieval process through an industry standard API, essentially simplifying the ETL process, extract, transform, and load. Graph enables the app to efficiently extract, organize, and load data into a Postgres database. It streamlines the data management and provides an API to query the data, enabling the apps for more flexible and faster querying and eliminating all the inefficiencies in traditional blockchain interactions. So how is GraphQL used? So GraphQL used in various pieces within the graph ecosystem. To start with, the GraphQL SDL, the schema definition language, plays a crucial role in the ETL process. It defines how you want to store the data, how you want to structure the data extracted from a blockchain, and how it should be loaded into a Postgres table. So here, if you look at my picture, it says entity. So entity is essentially a table in your Postgres, and all these things are you're extracting those things from the blockchain events. This structured approach ensures that data is accurately and efficiently managed throughout the transformation process. The second use case is for serving. So in addition to the ETL, the STL serves, we can use GraphQL as a query language to serve our database. So this means you have GraphQL to interact with the data that is stored in your database. And we all know how easy it is to query a GraphQL API, and we can easily explore what's available in our GraphQL API. But there are some challenges involved in this landscape when you're querying your subgraphs, because there's a decentralization aspect, and these problems are very similar to how you would see in any distributed system in traditional industries. So let's say you have a blockchain that has 1,000 blocks, and I have 2 different nodes essentially indexing your blockchain. So node 1 is indexed till block 980, and let's say the node 2 has indexed till 990. These are 2 independent systems with their own databases. Our users only care about the latest data. So the challenge is like, how do we get them the latest data? What happens if there's one node down? So users could also be indexing the same subgraph across multiple blockchain networks. Composability plays a big role, and the concept of subgraphs and supergraphs that we have in our community plays a crucial role in making a unified experience for people in the blockchain industry reading the data for different use cases they have. So advantages blockchain have is everything has a unique identifier. So you can have an address for some person on blockchain network A. The same address is consistent on blockchain network B. So you could essentially type merge both addresses across multiple networks, which is very powerful. So how can we generate a unified graph? Enters GraphQL Mesh. Mesh is a framework that helps you build executable GraphQL schemas from multiple different sources. You can run Mesh anywhere. You can query any GraphQL interface. So what Mesh does, you get a federation-compliant subgraph. So for any different source that you have, you get a federation-compliant subgraph, and you put them on your gateway, and you can serve all that data. So we actually created a wrapper around GraphQL Mesh for the graph called the Graph Client. It enables you to do client-side composition. Because most use cases we see federation is being done on the server side. There's some use cases you could have everything composed on the client side, so the client could actually be making these queries. There's a lot of features I have on the board, but mainly I would like to highlight live queries work out of the box. We use polling for that. There's a lot of features we offer, but there's still a few challenges that we need to solve here. So for the future, what we want to do in this blockchain ecosystem is, after talking to multiple customers and different apps using this kind of architecture, it boils down to everyone wants to compose their own data source with the blockchain data, and they want to know how their subgraphs being used. So essentially, it's all coming down to how you can compose your APIs. We have a big working groups happening within the GraphQL Foundation about composite schemas. So I think there are a couple talks happening this week, so you all should join composite schemas talks. There's a lot of advancements happening, and then future for GraphQL Mesh is bright. We announced our gateway, so there's a lot of things that mesh in together. So if any of this excites you, you can see it in action. My coworkers are running workshops later this week, so don't forget to check them out. And thank you so much for joining. You can come by our booth if you have any questions, have some coffee, and we'll share some swag. Thank you.